All right, students. So 3.5 says graphing quadratic functions in vertex form. So as you guys know, the parent function for the quadratic is y equals x squared. Now this is your HK form. It is f of x equals a times the quantity of x minus h, close it, square plus k. Now the a, as you guys remember, that's going to give you a vertical stretch or vertical compression. If it's negative, then there's also a reflection over the x-axis. The h is a translation left or right, and the k value is a translate upward or downward. Let's start with graphing the parent function, which is always, okay, so the parent function is always y equals x squared. We will pick 5 inputs, just like the absolute value function. So when we graph this, we're going to plug into the parent because that's what we're graphing right now. So -2, the quantity of -2 square is 4. Quantity of -1 square is 1. Quantity of 0 square is 0. 1 square is 1. 2 square is 4. As you can see, we are going to graph this out and it should really look like a U shape, okay? So -2 is 4, -1 go up 1. 0 is 0, 1 is 1, and then 2 is 4. Now, if we really wanted to, we can even do -3. Now, -3 is going to be 9, and +3 is also 9 because it's being squared. So, since it is a parabola, make sure you guys really round out the bottom. Now, sometimes you kind of miss the dot, just like what I just did there on -3, 9. You just make it really, really fat, okay? Your vertex for the parent is 0, 0. You do have an axis of symmetry, and remember, that's going to be the line that divides the graph into 2 exact pieces, okay? So that's going to be x equal to 0. It's also going to be the h value of your vertex. Your x and y intercept for this graph is 0, 0. The domain is going to be all reals, or it's going to be from -infinity to infinity if we want to write it as an interval notation. So I will accept all reals as well. The range is going to be y is bigger than or equal to 0, or if you like interval notation, is 0 to infinity. We do have a decreasing and increasing interval. So on this side, students, this right here is going to be decreasing interval. And that's going to be from -infinity to 0. Then on the right side of your axis of symmetry, that's going to be increasing interval. So that's going to be 0 all the way to infinity. The rate of change, we're going to say it varies because it's not a line or an absolute value. It is not a one-to-one. We have a minimum value of 0. And we don't have any maximum since this is opening upward, so none. Okay. We have 2 more examples to go. So example 2 to 3, it says identify your a, h, and k values and find the vertex, axis symmetry, list of transformations, and then fill out the characteristics, okay? So transformations refresher, just like what you guys did with the Desmos. If your a is negative, you're going to have a reflection over the x-axis. Reflection over x-axis. Now, sometimes you will hear one of the teachers say it's a vertical reflection. That is the same thing. Remember, this is called vertical reflection because if it's on the top, if it's opening upward, it's now going to open downward. So that's folding up and down, so that's a vertical reflection, okay? Now, if your a value, it's, as you can see here, absolute value a is less than 1, so that means it's in between 1 and 0, so like a half or a quarter or 7/9, anything like that, okay? So i.e. like 1/2, 3/4, 7/9, something like that. This is going to be a compression. It's a vertical compression. So vertical compression factor of whatever that is. So factor of the a amount, okay? Now, if a is bigger than 1, such as, so i.e., like 4, like 3, like 11, whatever number is bigger than 1, then this is going to be a vertical stretch. Vertical stretch. Factor of whatever number that is. Factor of, if a is 4, then factor of 4. So whatever a value. Now, if you guys remember, h is going to be a translation to the left or right. So if you have a positive h, then it's going to go right. So translation to the right. Okay. That many units, so h unit. Okay. If you have a negative h, then it's going to be translation, oh, you guessed it, left, h unit. Then similarly to the k value, if you guys have a positive k, instead of left or right, k is going to go up and down. So translation up, translation up, k units, whatever that may be. Okay. And then negative k is going to go down. So translation downward, k units. I would totally be happy if you could say, if you have a positive h, you can simply just write 4 units, for example. If you have a negative 3 for h, you can say left 3 units. If your k value is 9, then you can say up 9 units. If your k is negative 20, then you can say down 20 units, okay? Now, steps to graph in vertex form. Feel free to pause this to copy it down. Find and plot the vertex. Identify and draw the axis symmetry, so you know the left and right will be exactly the same. Make the table value for the parent function. List the transformation. Make a new table with values from the transformations. Graph your new points and find all the characteristics. And so that's what we are going to do. F of x equals the quantity of x minus 3 square and then minus 1 at the end. So we don't see a number in front of the parentheses, so that's always going to be 1. So a is 1, your h, okay, so let me write this down. Remember, f of x and y is the same, and the a, h, and k form, normally we just call this h and k form. It's a times the quantity x minus h square, and then it's going to be plus k. So this is already an x minus, students, so your h value is just going to be 3. Now this is a minus 1 at the end here, but the formula calls for a plus k. So we want to say, okay, well, if it's a plus k, then this could be seen as, think about it like this, right? Plus negative 1. So that's going to be a negative 1. So only inside the parentheses is when we take the opposite of what you see. If it's outside, then you just, if it's negative 1, you write k negative 1. If it's positive 5, you write k as positive 5. That is enough for us to state the transformation. We have 3. Actually, no, we only have 2. When a is 1, there's no transformation. What do you do when you multiply things by 1? It doesn't change. So you have an h value of 3. So that's going to be left and right. And since that's a positive 3, we're going to go right 3 units. Yes, I do want you guys to tell me how many units as well. Then k is negative 1, so we are moving down 1 unit. So an a value of 1 does not have a transformation since it will not change anything. All right, so first we are going to start with the parent on this table here. And the parent is always y equals x squared. So we are going to pick the same 5x value, students. This is an x squared, okay? Right here. Let me make it a little bit clearer like that. All right, so when we plug in -2, we should have 4, 1, 0, 1, 4. You should be able to get the parents very quickly. Now we are going to use your A, H, and K and transform. The A value will change your Y, so 1 times Y. Well, 1 times Y is Y, so that's why we don't really write 1 times Y, okay? Then that's also why we don't say A of 1 is any transformation at all. H is +3, so that's going to go right by 3. So right by 3 means we are going to add. K is -1. That means we're going to move down 1. So it means all your Y values are now 1 less. So we are going to take all the X values here. And then I want you to add 3. So that's what it means. So -2 plus 3 is now 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4, and 2 plus 3 is 5. Those are the new points that we are going to graph. Take all of your outputs, which is the X, and transform that by minusing 1. 4 minus 1 is 3. 1 minus 1 is 0. 0 minus 1 is -1. 1 minus 1 is 0. 4 minus 1 is 3. And let's plot the transform table, the purple. So 1 is up 3, 2 is now 0, 3 is -1, 4 is 0, and 5 is 3. Now let's make a nice U shape. Okay. If you can't make a nice U shape, try your best. Try to see if you can go up as far as you can. And sometimes graphing by hand is not going to be as good, but just try your best. Make sure it doesn't look like a V, okay? Now, let's talk about the vertex. The vertex is right here, H comma K. And the H value is 3, 3 comma -1, which it matches right there. This is your H comma K, okay? Right there. Now, we want to see, okay, is there an axis symmetry? Of course there is, right? Because if we were to fold it when x equals to 3, left and right should be exactly the same, which is asking for it anyway. So x equals to 3. That's the H value of the vertex. Let's fill in the vertex as well, 3 comma -1. We do have 2 x-intercepts. X-intercept is when y equals to 0, which is right here and right here. So let's write that down. So this one is really nice and simple, 2 comma 0, and then 4 comma 0. We have a y-intercept, we just can't tell, so we do have to solve it manually. Y-int, students, is when x equals to 0, so we're going to plug 0 in our equation, which is y equals 0 minus 3 is -3 square minus 1. -3 quantity square, students, 9. 9 minus 1 is going to be 8. So y-intercept, it's hitting us at 8. So that's going to be 0 comma 8. The domain of this is all reals, or we can use an interval notation, so -infinity to infinity. The range, the arrows are going upward, so we're going to say, okay, that could be y is bigger than or equal to the k value, which is -1, or we're going to say from -1 to infinity for interval notation. It is not a one-to-one. We do have an increasing interval. So increasing interval is from this minimum value right here all the way to the right. So that's an x value of 3. So increasing 3 all the way to infinity. That means, students, the decreasing interval, it's over here. So that's going to be from -infinity to that h value of 3. The rate of change, we are going to say it varies. Now for this one, because it's opening upward, we are going to have a minimum value of that k, and that k value is -1. So y equals -2 times the quantity of x plus 5, close it, square plus 8. So your a value is -2. H is -5, has to be opposite of that. K is going to be 8. All right, guys, there are 4 transformations here, believe it or not. I know there are only 3 numbers, but the -2 is going to come up with 2 transformation on its own. So the -2 is going to be like a -1 times a +2. So a -1 is going to be a reflection over the x-axis, okay? Reflection over x-axis, or you can even say vertical reflection. Then the 2, since that is bigger than 1, so it's going to be a vertical stretch, okay? Vertical stretch. And it's going to stretch 2 times as much, so stretch of 2. So meaning that the y value now will be twice as large as the parent. Not only that, it's now going to be upside down. The -5 is going to go left 5 units, so now your vertex is no longer at 0, 0. It's going to be on the left. And the k being 8 is going to be up 8 units. Okay, all of that's going to have to match, okay? So first things first, we're going to do the parent. So this is the parent equation, students. So y equals x squared. So same exact 5 inputs. And by now, we should be able to get the 5 outputs pretty quickly. 4, 1, 0, 1, 4. Then we are going to take the -2 and multiply it to the y. We're going to take the -5 for the h and subtract it from x, okay? Because that's a horizontal translation. Horizontal means you're moving left to right, and x-axis is horizontal, left and right. Then the k value, that's a vertical shift upward, so that's going to be +8. Translation up by 8, okay? So it's just like before, take all of the parent input and -5. So -2 minus 5 is -7. -1 minus 5 is -6. 0 minus 5 is -5. 1 minus 5 is -4. 2 minus 5, as you can see, is going in order. What doesn't go in order is really the y's, okay? The y actually kind of repeats. Okay? 4 times -2 is going to give us -8. -8 plus 8 is 0. 1 times -2 is -2. -2 plus 8 is 6. 0 times -2 is 0 plus 8 is 8. If we do this correctly, the bottom 2 values should be 6 and 0. 1 times -2 is -2 plus 8 is 6. 4 times -2 is -8 plus 8 is 0. So that is okay to have. Let's plot -7, staying at 0, -6, up 6. -5 is now 8. And then it reflects, okay? So this is really your vertex, and that's your axis symmetry. So mirror image that exactly. We know it opens upside down because there was a reflection over the x-axis, just like that. So there it is. Let's graph it out. I'm sorry, let's answer all the characteristics. Vertex is h comma k, so it's -5, 8. Axis symmetry is x equals -5, whichever the x value x. X-intercept, we have 2. Oh, look at this. They're so nice. Look at that. If you can't find it on your table or on your graph, then you have to solve it manually, which you do know how to do. So it's going to be -7, comma 0, and then -3, comma 0. Make sure there's -3. Y-intercept, we do have to find that manually because it looks like we can't see it. So y-intercept is when x equals to 0, okay? X equals to 0. So y equals -2 times 0 plus 5 is 5, so that's 5 squared, plus 8. So 5 squared is 25. 25 times -2 is -50. -50 plus 8, so y is going to come out to -42. That's why it's not on the graph, students, because it's all the way very low, which I don't have -42 boxes. The domain, we can say it's all reals, or you can also write it as an interval notation. Your range is going downward, students, so but the max y value is going to be 8. So we can say, hey, y could be less than or equal to 8, or if we write it as an interval notation, negative infinity to 8 and a bracket right there. Okay. Is it a one-to-one? Nope, not parabolas. Increasing interval is now going to be on this side because that's going up. Okay, so increasing is going to be from negative infinity to negative 5. So negative infinity to negative 5. Decreasing is going to be on the other side from negative 5 to positive infinity. Rate of change, we will say this varies. And we have a maximum value, and the highest y value is 8.